ask questions, you have that freedom. But when you're not speaking, try to be on mute, right? Perfect. And the agenda for today's discussion, today's demo, is to introduce all of you about a course that I'm coming up with Isha on SRE, Site Reliability Engineering, right? And we also have this cloud performance engineering and DevOps. So I'm going to talk about this course before we deep dive into the course curriculum, right? And all those things. There's somebody at the door. Just give me a minute.
Hey, Prasad, can you please go on mute? We're getting a lot of background noise from your side.
Okay, I'm back. I request everybody to be on mute, please. Okay, I can mute you as well. Okay, guys, sorry. So I'm back. There was somebody at the door. I could not ignore that. Okay, so welcome everybody to this demo session. So let me introduce myself. My name is Raushan. I have overall 17 years of experience in IT. I started my career as a Java developer, and then I have been into multiple roles throughout my career. Currently, from last 8 to 10 years, I'm working as a principal SRE consultant, SRE DevOps consultant in one of the reputed retail giant company. Okay, that's brief about me. On my hobby, I have teaching experience. I like to share my knowledge. From last 6 to 7 years, I have been teaching associated with multiple uh, institutes like Edureka, Intellipath, Simply Learn. Right now with HISA from last 4 years. Yes. So that's background about me. Okay. So before we get started, let me uh, talk about the agenda. So what are we going to discuss in this 1 hour or 1.5 hours, this particular demo session? So we're going to start the session with a question. And I would like everybody to answer that question. Okay. And then we will talk about how software has been developed and deployed over the years. So we'll talk about the evolution of software in general, the development and deployment. Then we'll talk about the course, what course brings, what is the course content, right? And we'll take up your questions, all your questions, we're going to take it up. Okay. So that's the agenda for this demo session. Okay. So here is the question. So first of all, this question is not just for the performance engineers. Majority what happens that in my group, wherever I take with ISA, I feel a lot of performance engineers because I have been into performance engineering myself. So I see a lot of performance engineers joining the session. So that's why I have given this headline as performance engineers. But this question is applicable to all the QA folks, QA functional, manual, automation, DevOps, DBAs, right? Developer. These questions in general, whoever working in IT company or aspire to work in an IT company. Okay. And now here is the question. So do we think that performance engineers or anybody working in the software company are expected to know this, all this DevOps, microservices, containers, and cloud? Looking at the trends that's happening from last couple of years, do we think that it is expected? Yes, obviously, or not required. You're able to manage without this knowledge. What do you guys think? You can unmute yourself or you can put in the chat. Feel free. Okay, so I've started to get the response. Sudhir uh, thinks that is expected. Okay, good. Sudhir, how about others?
I think it depends upon the project, from
Mhm.
the how they are going to uh, go ahead with the given task. That should be a
Okay, project you mean to say? May I know, Naveen, about your background?
yeah.
If you,
I'm from
what's your
DevOps.
background like?
I'm
DevOps,
from
right?
DevOps. Yeah,
So
yes.
if you are into DevOps, so don't you think that you need the DevOps knowledge or microservices, the understanding how it is being done, or containers
Yes.
or cloud,
Everything. Yeah. DevOps. It
right?
is required. Yeah.
Correct. So
DevOps.
just talk from the your perspective. Yes. So absolutely yes, right?
Yes. I can say
Right.
it.
The overall understanding of how things connect to each other, how they talk and communicate together, understanding is required for us
Mhm.
to go deeper on any specific topic. That's what I think.
Exactly. So irrespective of your skill, even if you are a performance engineer or a DevOps engineer or an automation engineer, right? Working or DBA or working or a software developer, anybody in IT, this is the generic thing because we need infrastructure to deploy our applications. And from where we'll get the infrastructure, we'll get it from the cloud. We are into microservices world. Now, to understand microservices, we need to understand what is monolithic and what advantages microservices offer, right? So nowadays, if I just say one line that nowadays all the development that's happening, the new development is happening in the microservices domain, in the space, and old monolithic is being converted into microservices because of the advantages, right? So we need to know, understand of microservices. And then where do we deploy microservices? We have this containers thing, right? And then we need one culture to operate in a very smooth manner where things gets deployed at the earliest. Let's say when the code is ready, when the developer is ready with the code gets deployed into production at the earliest. So we need that automation and that DevOps, right? So we need the code to be deployed at the earliest without taking a lot of time in the quality validations, right? So yes, irrespective of your field that you're working on, this is a mandatory stuff, right? I'm going to deep dive into each one of them. Maybe most of you, I'm not sure, but you may not have microservices knowledge. I'm going to touch base on that. You may not know containers, right? But I'm going to touch base on that. I'm going to touch base on each and everything here. So don't worry if you have not understood whatever we just discussed. Okay, so let's deep dive into this. So yes, overall, everybody is saying that it's required. Okay, now let's understand why these are required. To understand this, we need to understand the how software has been developed and deployed over the years. Now here is the slide, the next slide. And now you'll understand why those four things that I have mentioned is important. If you look at the how software has been developed and deployed over the years, right? Let's talk from the development process, the SDLC, software development lifecycle models, right? So when the software development started, let's say back in 1980s, it not long ago, right? 40, 50 years back, we're talking about. We had this waterfall model, SDLC model, software development lifecycle model. SD waterfall model had few a lot of disadvantages, but it's good to get started on something, right? One of the drawbacks of waterfall model that we developed everything, all the software, let's say anybody. So let's understand about SDLC first. Okay, let me open a notepad, okay, and give you just a quick recap on SDLC part. What is SDLC? Software development lifecycle, how we go about developing a software, right? See, everything starts with a problem statement. Everything. Let's say today, if I have business idea, and let's say I don't have much knowledge on how do we go about developing this software. So it starts with a problem statement. Think about applications like Make My Trip or any other websites, right, that we see right now or use quite often. So the owner who developed Make My Trip or who is responsible, the mastermind, may not be good at the software part, but he knew the vision of this company. Let's say Make My Trip example. So basically, Make My Trip, whatever you see is the Deep Kalra is the owner, mastermind behind this Make My Trip website that we see. So Deep Kalra is not a technical guy. He had this vision of this software that he wanted to develop. So he had this problem statement. Okay, that I want a unified way of ticket booking. Like earlier back then, if you have to book a flight ticket, let's say, people used to go to the airport and book the ticket. Right? That was the thing. How was happening. Even for if you even for the railway, if you guys might know that now we have this IRCTC, but 10-20 years back, like 15 years back, we used to go to the railway station to book a ticket. We used to get some agent somewhere and then they used to book on behalf of us. It was happening, the real thing. You guys experienced that. Now we have this IRCTC to go and we can book the train tickets, right? See, every software developer starts the problem statement that we want to solve a problem. And then we, let's say, consult any IT company and then we talk about how do we go about it. Let's say Mr. Deep Kalra had this problem statement and he approached, let's say, one of the companies. I don't know if it's actual or not. Let's say he approached Infosys or TCS, let's say, any company. Then they would have understood the requirements, right? The requirement gathering phase. What Deep Kalra thinks, right? Requirement gathering phase. What all could be the features, the home page look like, the different features, the requirement gathering phase. Then comes the planning and designing phase. People at software company would try to plan the software development and design the architecture part, the technology they would talk about, which technology they want to develop, the applications, and so on and so forth. And then the development, the real development would start. The project would be given to a development manager, and the manager would have few people, developers working in the team, right? And they would develop the software. And then there will be QA folks would be quality testing. The software could be a functional tester, performance tester, security testing, user acceptance testing, penetration testing, could be a lot of quality validation. So I'll put that into the quality validations, right? Quality validations. It could be functional testing, it's a performance testing, security testing, penetration testing, could be security, let's say UAT testing, and finally I'm going to deploy the code to production, right? That's what happens. That's what SDLC we talk about. Obviously, after development, we need to build the software. Like could be a jar file. If it's a Java application, we'll build it, compile it, unit test it, build it. You can use some tools like Maven, right, to build Java applications, right? We get jar file, war file, we'll deploy it to some application server, or it could be containerized also. Depends on the process, what's the maturity level or how things are getting deployed in any company. So I'm not going to go in deep dive how it's getting built, where the code is getting GitHub, right? So code repository, obviously there are so many developers, they would use some GitHub kind of a code repository, right? So you are on video, you want to continue? Ravi, yeah, thank you so much. Okay, so let's say to build this, right? Then after that, obviously, the deployment part, right? So again, after I build the code, I'm gonna deploy it to some QA environment, deploy to some lower environment, QA environment. I can do all the testing. I can deploy to again performance environment. I can do performance testing. There could be various environments or same environment. It depends on the company to company, right? And then finally, I'm going to deploy the code to production. That's what happens. The life cycle, software development life cycle, like brief. So when we talked about, like, are we good with this, right? Everybody, very common thing, right? Everybody knows that how we go about developing the software. So in SDLC, what happened? All the requirements that, let's say, Deep Kalra has listed, gonna develop first. You first develop everything. It took you take 1 hour, 1 year to develop all the features, and then you start to test. That was the philosophy of the waterfall model, the approach, because we did not understand the problem initially. So that was the approach. What is the problem with waterfall, guys? What do you think? Let's say if I just build the entire like requirement software at once, and then we start to test later after a year, what can happen? Anybody?
Yeah, if the client comes with some new expectations, again, we need to start from the scratch.
Okay, that's good valid point. But think about something, some very critical thing. See, you're not testing the software. Meanwhile, there could be some architectural flaws, right? Let's say the application is not scaling. What would you do after that? After a year, you found that the application is not scaling. Can you go back and re-architect your application? Is it simple enough? No.
It won't be
So
possible.
it won't. It's very costly that those changes, right? So we learned from our mistakes of waterfall and we moved along, and then we talked about agile. We adopted agile around 2000. Still we have agile. In agile, what did we do? We split the development, all the development into phases. All the software development we split into phases. Let's say I'm going to develop one few modules, or it's a piece of a code. Let's say I told to Deep Kalra, Mr. Deep Kalra, in the first phase, we're going to create a login page, and we're going to show you how this page looks, right? And then you can give us some of your feedback. We'll incorporate your feedback, and then we'll go about developing the next few features, right? Next few features could be your other functionalities, right? So and we're going to keep on taking the feedback, and we'll for each this subset, for all these phases, we call this phase called sprints. For all these sprints, we're going to do all the process of SDLC. We're going to test, we're going to check the quality, we're going to deploy things, we're going to do functional testing, performance testing, security testing. We're going to do all the testing for each phases, right? And after completing one sprint, we will take we'll take the feedback of the client, and we'll incorporate the feedback and move along with the next phases. So a lot of advantages, right? So the end product is going to be very much in line with what the client is expecting. We would not get a surprise after developing, after let's say 2 years of development. We are not going to get a surprise. Okay, what happened? What could, like, we would not get a surprise. It will be a linear development, and we are testing the code. The features are getting implemented, right, time to time. So we learned, right? And that's the agile for you. So we learned from our mistakes of waterfall, and we adopted agile. So still nowadays, a lot of companies use agile. So, but there's one more problem of in agile. So let's say let's say for each sprint I'm talking about, let's say developer is ready with the code. Developer is ready with the code. Now, what is the main goal? Let's say when the code is ready, what is the main goal? Main goal. Yes. What do you think? When the code is ready, let's say developer mentioned the code is ready. What is the main goal?
To deploy it.
to test the application.
Where? Deploy where?
In server.
In that's fine.
Get
But
into
which environment?
production.
Production, right? That's the main goal.
Infrastructure.
Come again.
Infrastructure architecture to deploy.
Right. But which environment? Where to deploy? I have QA environment. I have pre-prod environment, functional environment, performance. There are so many environments, and we need infrastructure in across all the environments. What is the main goal? Main goal is to deploy the code to production, right? Production environment. But we cannot take that risk. That's why we do quality validations. Right? So we do functional testing, performance testing, we rage bugs, we check functionality, we test performance testing, we check if the application is scaling or not. On security testing, we check is my application secure or vulnerable to security threats. We do all sorts of testing, right? Before we deploy the code to production. And in Agile, this process takes a lot of time when done manually. Let's say, if just think about it, let's say this process takes a month time, full month time to complete this quality check. Would anybody like it? Like, my code is ready 1 month back. Why this process quality validation takes one month? Nobody likes that. And that's happening in Agile. So how to improve it? Bring automation. Why can't things get automate? When the code is ready, developer has pushed the code to, let's say, GitHub, any online code repository. Take the code, build it, automate the entire process, build it. After code has built, deploy the code to QA environment, testing environment. Why can't functional tester or automation tester can write a script which can trigger automatically, right? Trigger it automatically. It would run all the functional testing. It will give us the result. If it looks good, then performance job can get executed. It could be done in Jmeter. We can do this CI/CD pipeline using Jenkins, right? Then security testing, right? And then everything looks good. Deploy the code to production. Why can't this be automated? It makes absolutely sense. Yes. And that's what DevOps talks about. DevOps talks about SDLC process automation. Wherever possible, bring automation. Do SDLC process automation wherever possible. And that's what DevOps focuses on. DevOps focuses on SDLC process automation. Are we good with this, guys? Waterfall, Agile, DevOps. What are we going to talk about it? So DevOps is like Agile, but understand with automation. So think like that. DevOps is Agile with automation, so that when the code is ready, it gets within less time. We see, we are not talking about skipping. Don't do quality validation. No, we are not mentioning that. No, we have to do quality validations. We cannot take a risk or directly deploying the code to production. There could be functional defect, there could be performance defect, there could be security defects, right? And the repercussion could be a huge. Think about, right? Let's say Flipkart kind of application, Amazon.com, like an application where we think from the security perspective. Security is very important. Think about how we host our personal information to those websites. A lot of people save the credit card details to those websites, and if, let's say, somebody hacks the website, get your information, think about what could happen. Forget about performance. Security is also very important. So functional, performance, security is very all important. Before we deploy the code to production, we need to check, is my application code secure enough to get deployed to production, right? So that's the DevOps. So that's why we're talking about, we are in a fast-paced environment. We cannot wait months to get this process quality validations done, right? It has to get automated, and that's why there rise performance engineers. If most of you, I believe, are performance testers, right? We are automating using Jmeter, Jenkins, or LoadRunner, Jenkins. We are being a part in CI/CD pipeline. automation engineers working in Selenium, right? Or rest assured, we can integrate with Jenkins, right? When the security testing working with, let's say, tools like Fortify, right? We can automate things working in Jmeter, and things can get automated, right? And that's what DevOps focuses on, right? So that's the importance of DevOps, and that's the where we live in. This is the current technology that we're working on, where we talk about automation for everything, irrespective of the skill. Functional testing, performance tester, security testing, automation is going to be very important, right? So that's about the DevOps part. I hope are we good with this, the first development process. Everybody, any questions, please give me a thumbs up. If you're all good, type yes in the chat. If you have any questions, please ask. Yeah, Naveen, go ahead.
No, sorry, I'm good. I was saying, sorry.
Okay, you have raised the hand, right? So
Yes.
you can lower your hand. Okay, perfect. Now moving along. So what is this monolithic, right? See, when the software development started, we were developing monolithic applications where we put a lot of code, every code together, packaged together. We just package every code together in monolithic applications. Okay. What I'm going to show you, I'm going to share a quick diagram with you. Give me a minute. Okay, just give me a minute. Okay, just 1 second, guys. Sometimes this sharing creates problem. Give me 30 seconds. Okay. And okay, I want everybody to just focus on this diagram. Okay. And to understand what is monolithic and microservices. See, what is monolithic applications and what is microservices? Let me make you understand this. So in monolithic is the application where a lot of code. So let's focus on this. Let's say I have working on a 3-tier application. Let's say I'm working on 3-tier application. Let's say I'm working on web server. I have app server and let's say database server. Okay. Focus on the app server where we have the logic, application logic, code, methods all put together, right? Let's say I have got a lot of functionalities of in my website. Think about any website, whatever website you think good enough. Let's say I have got a lot of functionality, and obviously I have a lot of functions there, right? Let's say, and let's say I have got, consider like an application like e-library applications, or let's say Flipkart. Think about Flipkart. I have one module, let's say for electronics, right? Or I have flight tickets also. Flipkart has that, right? For different use case, I have different modules. And for each of the modules, let's say I have the functions, various functions, 20 functions in module 1, let's say 30 functions in module 2, again 20 functions in module 3, and again let's say 30 functions in module 4. In monolithic applications, we package all the code together. So what does it mean? Package all the code together. So basically we write the code, right? Let's say we start writing a Java project, then we create, let's talk about Java project. Still, Java is still the most popular language in the enterprise development. That's why I'm talking about the Java. Let's say we start with the project, we create package, and then we write classes, right? We define objects, we write functions, and so on. We keep on doing that for various packages. In monolithic applications, the functions from each module calls another functions across modules. So the functions are being called anywhere and everywhere. So there is a huge dependency in the case of monolithic applications, huge dependency. So when I say huge dependency, if I'm writing F1, let's say one of the functions in M1, I can call other functions. I can create an object and I can call or import the package. I can call. So there's a huge dependency. So monolithic. So if you look at the meaning also, right? Mono means single, lithic means big, single big unit where we put all the code packaged together from a lot of functionality put together. What is the problem with this? The problem is this. Let's say issue with one of the function. Let's say I have issue with F1. Some code I'm writing, some function I'm writing, and let's say the issue with my logic. Some bug is there. It's not getting through, right? Let's say issue with one of the functions. This function, issue with one of the functions, can create problem for M1. It would not be able to compile M1 correctly. The F1 issue with one of the functions in M1 would not let M1 to compile correctly. And then since there's a huge dependency, there's a potential risk that even other modules can get impacted because M1 is being called at multiple places. If M1 is not working, again, there could potential risk because of one issue, the entire application could go down. Potential risk. Yes or no? Because there's a huge dependency. Do we all agree on that? That if wherever the huge dependency is there, one function can create problem and it can impact everything. This happens because there's a huge dependency there. And that's what the problem with monolithic applications. So what is the solution? Solution is to break it down, make it independent, as simple as that. Create different microservices. So I can break these modules M1, M2, M3, M4. So what does it mean breaking? Breaking means I'm not going to call the function directly. I'm going to get different packages done. Let's say here I was getting one jar file or a war file. When I packaging this entire application, now I'm going to get multiple jar files. For each module, I'm going to get one jar file. Now my module 1 can get deployed independently of M2, M3, M4. If I'm fixing something in F1, I don't need to deploy the entire code base of M2, M3, M4, which was not the case here. Now, because since it was huge dependency, even if I'm fixing one of the function, I have to deploy all the other code also. So you guys would have noticed that in the case of monolithic application, we cannot do frequent deployments, quarterly deployments, right? We go for quarterly deployments, 2 months, one deployment. It's very slow deployment because we have to deploy all the code base. In the case of microservices, we can do frequent deployments. You may be working on weekly deployment or daily deployment. We have a CI/CD pipeline, can do a daily deployment also. For even small bug fix, I can deploy my code. I can deploy M1. So I'm not going to redeploy other modules. If issue is one of the function, it's one of the module, I can fix this and I can deploy this. Right? So the solution is to break this, make it independent, and that's the independent. Each module is what we call it microservices. And there's a huge advantage of microservices. I can deploy them independently. Since I'm not calling the functions, I can write M1 in Java language. I can write M2 in Go language. I can write M3 in Python language. I can write M4 in Node.js because I'm not calling the functions. These can be independent technology. So if M1 needs some information from M2, how they would do that? So using REST API call, get call, post call, they would call it. If there is information required for M2, for M1, I can do a get call, post call, get the information. Like how make my trip calls Indigo. So if you look at the make my trip website, when we do from and the source and destination date, and we give the place's name, right? Source and destination, we give the date, we get a list of all the flight options. So do you think Make My Trip own all the flights carrier? Indigo, Air India, Air Asia, whatever you see. Do you think so? Make My Trip owns everything? Or Make My Trip has database access? Do we think so? Everybody?
No.
No.
No. It doesn't happen that way, right? The Make My Trip calls API. Indigo, Air India, they have exposed API. They have given the API details. They have purchased Make My Trip or Clear Trip. They have purchased the APIs of these Indigo, Air India. They call the API with all the information, get call, post call. If I'm booking the ticket, that would be a post call. If I'm getting some information, that would be a get call. So we call the API and get the information. Make My Trip, all it does is just put that in a better view, in a sequence. Ascending order flights on the basis of time, on the basis of cost, right? All those, that's what Make My Trip does. Those are all API calls, and that's how microservices communicate with each other. Do you think if Make My Trip website is down, do you think Indigo website would be down?
No.
No.
No. What? Those are two independent websites, even independent things. So that's treat microservices like that. If M1 is fine, if M1 has issue, it's not going to impact other modules M2, M3, M4. Right. So nowadays we have this on mobile application. Let's say Swiggy. Whenever we order a food item, we get a notification that my food has been ordered or had been delivered. One of the features is that notifications. If notification is not working, it's not like I would not be able to order my food. No, those are two different functions, two different modules. Right? Yes, I see a hand raise. Anybody? Please go ahead. Yeah, please ask your question, those whoever raised their hand.
No. It was by mistake.
Okay, perfect. Okay, so that's how. So microservices, right? So we have a lot of advantages. We can, independent on the technology, my issue with one of the modules not going to impact other modules, right? A lot of other advantages, right? So that's why we're talking about this microservices, right? Monolithic to microservices, and we are not all the development is happening into the microservices, and even though those are monolithic, it's being converted to microservices in a very planned manner. Are we good with the second part, application architecture? Everybody, give me a thumbs up or yes in the chat.
Yes.
Okay, perfect. Now coming to the servers, right? Because see, we're talking about the application, fine, but we need to deploy somewhere. So basically, we deploy the monolithic applications in the VMs. I'll tell you the brief history about that. So let's say when the software development started, right? We started deploying software on physical server, which has a lot of core or resources, I would say, a lot of resources. So what I'm going to do, I'm going to just share one more diagram with you to make you understand. Okay, just take this. So when the software development started, we were deploying small, tiny little application, few KBs, MBs application on a big physical server. Big physical server, we were deploying few KBs, MBs application. What is the problem? Wastage, resource unutilization, right? This was happening back then. Then there come a technology called virtualization. What we did, we took the same physical server and we could create multiple VMs. We installed a software, we deployed a software called virtualization software. VMware, VirtualBox, Hyper-V. We have a lot of virtualization software we deployed. We installed the software and we could create VM1, VM2, VM3 of different shapes and sizes. Now, in the same physical server, I can create multiple VMs and we could deploy multiple applications. Let's say In VM1, I have web server. In VM2, I have app server. In VM3, I have database server. So we were able to do much better from this physical server to VMs. Nowadays, from 8 years, 9 years back, there came a technology called containerization. What I'm showing you is one VM. What I'm showing you here is one VM, VM1. We can deploy one application, one software called container engine. The blue here, container engine. We could install a container engine like Docker, Rocket, Containerd, Podman. We can install a container engine on the VM and we could create multiple containers. Think like a process. Containers are nothing but a process. Why we did that? Okay, so over the years, it was found or observed that even for the VMs, we are not able to utilize the VM to its full capacity. Mostly the VMs are 20 to 30% utilized. We are not utilizing the VM capacity. The core, the RAM, we are not able to utilize that. So why can't we break this VM? Why can't we come up with a technology where we can run multiple applications in one VM itself independently? And that's what containerization did. Around 2015, this technology came from Docker and Kubernetes from Google, that in one VM, we can create multiple containers and we can deploy in these containers. What we can deploy? Microservices. So that we can utilize the VM capacity to its full capacity. It resulted in a huge cost saving across the company, across the industry. And that is why it has become a de facto norm now. It has become a norm. Any company that you go, you're going to find they are working on Docker, Kubernetes. There's a reason for that because it did the cost saving. For any company, the majority of the cost, if they're in the cloud, the majority of the cost is for the VM, virtual machine, nodes, the cores, the CPU, right? And if you could optimize that, the resource, if you could optimize the resource utilization, we can do a lot of cost savings. And that's what containerization offered. And that's why nowadays Docker and Kubernetes, if you see, every company is adopting that. If you are in a setup where you have applications deploying containers, it's good because that's where we are heading. It's already been, people are using it. I see wherever I work from last 8 years, I'm seeing that. I believe most of you are also working in containerization technology, right? Yes or no? How many of us are working here in Docker, Kubernetes here?
Yes.
Right, Naveen? How about this?
Raushan, I'm working with the virtualization part and the cloud part, but I have a little bit doubt in this containerization. I am not aware of this technology. We are planning to implement this in an environment, and that's why I've joined this session. I just want to, can you emphasize a little bit more? Yeah.
Right. It's the trend, okay, Ravi. Maybe in your organization they are still in VMs.
Yeah,
Right?
we
Maybe
have
the application is
human
big
cloud.
enough, monolithic
Earlier we had
applications. They are
physical
not
server.
into microservices, maybe,
Yeah.
right?
Okay. Yeah.
Right. Because the monolithic suits well with VM, right? But in microservices, whenever we talk about micros, all the recent webs, take Swiggy, Ola, Uber, Razorpay, think about any Walmart, right? Think about any ongoing Hotstar, Geo, everybody is into the containers. Every company. Right? That's the trend. Okay, good. Ravi, we'll take up your questions later on bigger doubt, right? Part later.
Yeah, sure,
okay.
sure. Take it.
Okay. That this would not be the right time. We'll take up your questions, right? So that's the trend, and the major reason is the cost optimization. That's the driving factor. Cost optimization through efficient utilization of the resources. And we are splitting monolithic to microservices, and we can deploy, and we can also mention that, okay, let's say this VM is 8 core, let's say 8 core, 32 GB RAM, right? Let's say we can create containers and we can deploy microservices on these containers, and we can mention that, okay, this container would take 2 core. So I can create 4 such containers. If one container takes 2 core and I have 8 core in the VM, so I can create 4 containers. And I can have one container for web server, another for app server, another for database server. I can have that. So in one VM itself, I can run a 3-tier application independently without any problem. Right? So basically, the idea here is to utilize the resources of a VM better. Let's say if you think, if in the VM itself, let's say you are 80% utilized or 70% utilized, then you will not get a lot of savings in the case of containerization. Right. I request to turn off the video. Thank you. Okay, so that's about the microservices part, guys. Containers, so physical servers to VMs to containers. And microservices, where do we deploy? On the containers. Are we good with this? The third part, deployment and packaging. Everybody? Ravi, you have a question?
Yeah, that
Okay,
kill
go ahead.
virtual machines, it's fine. How to break them into the containers? That's what my question is.
Okay, how to break down? So you need to use a container engine.
Okay.
I can show you some other time, but right now I can only tell you that you need to install, like for virtualization to create VMs, you had installed a software, right? Virtualization software,
Yeah, that's I understand. Yeah.
hypervisor. So
Yeah,
you
yeah.
created VMs, right? So now
Correct.
you take one VM and you need to
Okay.
install application like Docker.
Okay.
Once you install Docker, that's going to virtualize the OS. And then
Okay.
you can create multiple containers and you can deploy the microservices on these
Okay.
containers.
Okay.
Okay, so I'll talk about the course and then you will understand, you can relate it that we're going to do all those things in the course. Okay, I'll coming there on the course part. Okay. Now, this part,
Yes.
we're good. Mhm.
Hmm?
Yes, go ahead. Any questions? Ravi, could you lower your hand? Anybody, any questions? Okay, perfect, good. Now, coming to the last part here. Earlier, if you have a business idea back in 1980s, you have to set up your own data center. And setting up a data center is a very costly affair. You have to procure the land, construct the building, purchase all the servers, take care of the security of the data center. Your business would grow or would not grow, depends, right? So basically, a lot of investment was going to the data center. But nowadays we have cloud where others have set up the data center like AWS, Azure, Microsoft Azure, GCP, Google, GCP. They have set up the data centers. We can use their servers, we can use their storage, we can pay some amount like monthly bill, cloud bill to them, and we can use the servers. And that's the cloud. And that's where we use the cloud services as the infrastructure, where we have the cloud in all the infrastructure that we need to deploy my applications, to load balance, all the routing, all the networking, everything we can leverage from the cloud, right? And we have so why so many startups nowadays? Think about, because getting a server is not a problem now, right? Even if you have $5,000, $10,000 monthly bill, you can run you can host a good application. A lot of users can simultaneously work in, right? And that's why you see so many startups coming along, right? I hope now everybody understands why these 4 DevOps, microservices, containers, and cloud are important nowadays in current scenario, irrespective of the skill that you are working on. Why these 4 are important? Because that's the current scenario of the IT, right? Is everybody understands now this question? Quick thumbs up, guys. Any questions? Good part, guys. Okay, now coming to the course. Okay, so the course that I'm coming up with is comprised of all the things that we have discussed, right? All the things that we have discussed. So in this course, we are taking up cloud. We're gonna take up AWS cloud, and it's the scratch. Okay, it's from scratch course. There's no prerequisite for you to have it. Yes, troubleshooting part. If you have a troubleshooting background, if you want to excel in your SRE career, there are some skill sets required: automation skill set, some troubleshooting skill set. If you have some already, if you're working in such a technology where you are troubleshooting issues, or you are part of automation, it's going to play a very important role in the SRE career. Okay, but this is the course curriculum. Here we will talk about everything from scratch. Whatever we are talking about in this course, we'll on the cloud part, we'll take up AWS. Okay, so meanwhile, what I'm going to do, I'm going to also show you the, let me so introduce you the link. Okay, this is the link. Okay, I'm going to talk about the topics that we have in the cloud. So let's say if I show you, let me give you the link, everybody. First, this link. Let me share this link to all of you. Okay, I've shared the link. Now, here comes the cloud part. So we are taking up AWS here in this course, and we will be talking from very scratch. What is cloud? How different it is from on-prem? That would be our first thing that we're going to understand. And what is cloud computing? And then we'll talk about AWS, how to create an account in AWS, what is free tier, what all you can do in free tier in AWS. We'll talk about the use cases of cloud, the servers, the storage, right? The load balancing, auto scaling group as a performance engineers, very important from production reliability. Auto scaling is very important, right? Load balancing and auto scaling. We'll talk about that. We'll talk about databases services. We'll talk about networking. What is VPC, right? So we're going to have a lot of things which is required to be like just enough knowledge. So I'm not claiming you would be a pro in cloud, but you would have decent knowledge what an SRE engineer is expected to have, right? Or a DevOps engineer expected to have, or a performance engineer expected to have. We're going to learn that thing here in the cloud part. Now, that's the first thing. The second thing is the Linux, because see, believe it or not, you might be knowing the 95% of the enterprise deployment happens in Linux system. And we need to be very good at Linux because because maybe we are deploying applications or troubleshooting applications or checking the logs, right? Navigating between directories, right? So the Linux is very important. What I have observed that we are comfortable with Windows because it's a UI based, but we are not comfortable with Linux. So that's why we have this particular thing where we take up from scratch and we talk about all the things, the navigations, what it's see, Linux is all about commands. Is all about commands. How do we navigate within directories, right? From scratch. How do we check logs, grep? So a lot of things we're gonna from scratch, and we take up the very important performance from the performance monitoring, Linux performance monitoring. The other commands, you're gonna understand these commands. So what I'm going to do, I'm going to also show you the PPTs that you would be getting as part of this course. Okay, let me do one thing. I'm gonna show you, okay, the PPTs on the cloud part, right? This is the PPT. By the way, all these documents would be shared with you. Okay, those who are getting enrolled. Okay, not all of you, those are getting enrolled. Okay, so this is the cloud PPT where we talk from very scratch, and we will talk about a lot of things that we have discussed there. Okay, so I'm not going to just talk about topics here because we may not understand all of you, right? I don't want to think like a right. So we have a lot of things. Okay, you can see I'm going to just show you the slide number of slides. We have approximately 150 slides. Okay, 170 slides we're going to have in the cloud part itself. The cloud part itself takes 3 weeks. Okay, 3 weekends. Right, that's the cloud part. Coming to the Linux part, right? The Linux and shell scripting part. And we will take it from scratch. Everything is from scratch. We'll talk about directory navigations, all the commands that we require here, right? We start from shell, bash, right? And then we'll talk about the commands that we have for directory navigations, uh, for file and directory commands, right? So as you can see, system informations, and all the way till performance monitoring, shell scripting, you could think of, right? So we're going to take up that. That's the second part, by the way. And this is going to be the, see, there are, this course, right? We have, this course goes for 3 months, okay, 40 hours approximately. And we meet over the weekends, Saturday and Sunday, 2 hours Saturday, 2 hours Sunday, 7:30 to 9:30 p.m. IST. Okay, you can convert as per your different time zone. IST, 7:30 p.m. to 9:30 p.m. IST, 2 days in a week, 4 hours a week. And this course approximately takes 40
You said
hours.
7:30 to 9:30 IST, right? Sorry.
Correct.
Okay, thank you.
Right, so it takes approximately 40 hours. The live sessions is going to be for 40 hours, and we are covering a lot, so we cannot complete everything in the live session. So what we have done, we have split few things, the important things or the most complex things we take up in the live sessions, and we also share some recorded sessions, my recorded session, and then you can go over those recordings and ask questions. For example, what I have done here, we have mentioned here the whatever the recorded session that I'm going to provide is going to be like only recorded videos. It's not like that I cannot take it up. It's my recorded session itself. If you have any questions, you can come up and ask questions in the next day. We're going to take up that part first, right? But we have split that into, I would say, 30% recorded and 70% live. And that's how we are able to complete or take up a lot of topics here. This cloud part is complete live sessions, complete live. There would not be any recording, just recording provided, complete live sessions. Linux is going to be the recorded session because it's all about commands, basic stuff, okay, and you're expected to know that. If you're starting from scratch, those 3 hours of recording would help you. I'm going to show you how the recorded session would look like. The live sessions that we're talking about, this is the live sessions of recently concluded one of the batches. It started around, as you can see, 16th March, and it has concluded this last weekend. Okay. So this is the last weekend. This is the last weekend, last batch. Okay. And you can see this, all the sessions are being recorded, the live sessions, and it completed around the last weekend, right? It has been till 29th. So approximately 40 hours here. Okay. Yeah, that's going to be the recorded session of the live sessions. And then, as mentioned, that we're going to have some other, let's say, shell scripting, Linux shell scripting. So I'm going to share this 3.5 hours of sessions is going to help you with that. It's my recorded session itself. On the day one itself, you'll be expected to complete that because Linux is a very fundamental thing and everybody should know that. If you don't know ls command, cd command, chmod command, you should be knowing that first, right? Yeah. So that's going to be the Linux part. Moving on. We have the topics of SRE here. We'll talk about what is SRE, what is the expectations from an SRE engineer, We'll talk about the terms like what is the reliability mean, fault tolerance, high availability, DR, disaster recovery. We'll talk about the deployment process. What is blue-green deployment? What is canary deployment? What is rolling update deployment? We'll talk about the deployment perspective. We'll talk about these topics, right? What is SLO, SLIs, SLOs, SLAs, incident management? How do we do that? Roles and responsibility of an SRE engineer. We'll talk about that. Going to be completely live. Then we talk about the architecture of the software, monolithic, microservices. Where do we deploy microservices? We deploy on the Docker, right? We use on the containers. So how do we create containers using Docker? So we'll talk about that. Everything is hands-on. Okay, everything is hands-on. Theoretical is like 20%. While explaining, while showing you in the commands, all those commands we're gonna show you, and that theoretical part we're gonna cover, right? But everything is hands-on here. The Docker, the Kubernetes, right? The container orchestration engine, what it is, what is HPA, what is cluster autoscaling, how autoscaling works in Kubernetes, why Kubernetes, what different it is from Docker, right? We'll talk about that. We'll talk about DevOps, performance engineering and DevOps. What does CI/CD pipeline? How do we create? So we'll talk about continuous performance testing in DevOps. How do we do that? How do we create Jenkins? How do we create a Jenkins job for performance testing? We'll talk about Jenkins here, and we'll understand how a CI/CD process works. We'll talk about Jenkins file, freestyle job. We'll talk about these things here, right? This part, the Jenkins part. So DevOps. So basically, whatever we just discussed right on the slide number 1, right? DevOps part, microservices part, containers part, cloud part, apart from that, Linux, the SRE, right? Troubleshooting, right? So we're going to talk about additionally. So we are covering on these things plus other things like what do we mean by resiliency and reliability in AWS? How do we achieve that? Different services that we have in AWS, how do we achieve that? We'll talk about that. Observability, we'll talk about observability. We'll talk about Linux monitoring, CloudWatch, Prometheus and Grafana, and Elk. These 4 things on the monitoring perspective. From the observability perspective, we'll talk about that. Then on the troubleshooting part, we're going to talk about Java performance engineering. How do we work on Java performance engineering? Again, it's going to be the self-paced recorded sessions, my recorded session itself. So let me show you the playlist of Java performance engineering. So it's going to be my playlist and going to be this 9 where we talk about GC algorithm, what is performance engineering, JVM architecture, heap dump, thread dump, GC log analysis. We'll talk about the various GC algorithms, how it works from a Java performance engineering. We'll talk about that. From a troubleshoot, which will help you troubleshoot applications, right, in production. See, why SRE? Because we talk about troubleshooting applications in production systems, and that's why that's the main role of an SRE engineer, to make sure that the production is highly available, reliable. You don't have any performance issues, or customer do not have any performance issues. And that's why this observability troubleshooting part becomes very important. Yes, there are live sessions, Krishna. So yeah, that was the next topic. So coming to the automation part, see, wherever you don't see this, right, self-paced, that's going to be live sessions. Okay. So these are going to be the live sessions. The Terraform, the Ansible, right? How do we do CI/CD pipeline using Jenkins? So all these automation is what we're going to talk about. Going to be the live sessions. Apart from, yeah, Krishna, anything?
Yeah, nothing. Good.
Okay, good. Apart from that, because as an SRE engineer or as a Java performance engineer, we need to know the Java. So we have given a recorded session for Java. If you're starting up with Java and Python, these are not my recorded session. Somebody else at ISA has done that. Okay, but they are good. check that. So we have given the recorded session of Java and Python as well. So it's a complete course. Okay, it's a complete course, and that's why we have split that into recorded session and live sessions. It's a complete SRE cloud performance engineering course that we have here. Any questions, guys? That's about the course. I hope I have shared the link with all of you. Yeah, go ahead. Go ahead. Any questions? Feel free to ask.
So
Just
do we record all the session on the weekend? Suppose if I miss some classes on any of the weekend, I'll be able to get from the recording.
absolutely right. That's the first thing I showed you. So let's say this is one of the recordings of the last batch, right? Which concluded last weekend. So all the recording sessions are given to all the people, those
Okay.
who or the candidate, those who have joined. So we have given all these things.
Okay. Okay. And second thing, do we have access to any of the lab where we can get hands-on?
Correct, correct. So we're gonna work, we do gonna hands-on in AWS. So everybody, I'm gonna guide all of you to create an account in AWS, and I'll make sure I'll give you tips. How do you how will you not pay the amount, right? You'll not get charged. If you follow my instructions, you'll not get charged. You can manage your hands-on with free tier without paying any amount, right? So we're gonna do hands-on in the AWS. We'll talk about services here. We'll talk about EC2, S3. We'll talk about VPC, IAM, EKS cluster, Kubernetes service. We'll talk about so a lot of services, database services. We'll talk a lot about AWS services, and everything is hands-on. I'm gonna do things here, not gonna just talk about okay, this is EC2, that's what it does. No, I'm gonna show you everything hands-on.
Sure. Thanks. Thanks. Sir. And third thing, sorry. So suppose if we are aspiring to do any of the certification for any of this, so will you be helping us on that?
See,
Or guide?
I can see I have done certification myself, so I can guide you. Okay, what additionally you need to learn, because there are few things that you need to know as part of certification, right? So definitely we will be covering 60% of solution architect. Okay, if you ask me cloud solution architect, 60% will be covering.
Okay.
The remaining 30, 35%, 40%, I'm gonna help you with that. How can you approach that or plan that, right? So yeah.
And specifically for SRE, right? Do we have any related certification or anything
Okay, so
related to that?
as part of this, we are not supporting any certification, but you can do any certification anywhere outside. Okay, and that is whatever we are covering. It's more than enough that anybody can ask in any certification exam.
Okay. Yeah, sure. Thanks. Thanks.
Sure. Okay. Abhishek has asked a question. One second. Abhishek has asked a question. Once the course is completed, what should we be able to do? How can we stand apart after this course? Can you also please talk about success stories from your past station? Okay. See, people have been able to switch their career, okay, and they have been able to get a good understanding of each of the topics that we have covered, okay. And now see, I'm not going to prepare you for the certification or your resume or your interviews. Okay. I'm going to give you knowledge here in a very simplest manner. This is what this course does. I'm going to give you knowledge, and you need to have your own plan. What do you want to achieve in your career? How are you seeing yourself? Right. You need to decide your career, and you can ask the right questions. And whatever we are discussing in this course, I'm gonna make you understand that in a very simplest manner. So there is nothing like you cannot clear any of the interview, DevOps or SRE after this course. So if you know cloud, think about it. Think simple, Abhishek. If you know cloud, if you know Linux, if you know Docker, if you know Kubernetes, if you know Jenkins, if you know Terraform, Ansible, if you know Python scripting, shell scripting, tell me, would you be a difficult thing to crack an interview for you? Simple. I'm going to ask this question to you. Let's say you know all of these things. But I cannot promise you that you will be able to crack, right? That your dedication, right? If you're dedicated, I can commit on your behalf. Because you need to learn, you need to practice. You should not skip sessions. You need to do the practice, right? I'm going to show you the demo. But you need to practice. That is your part also. If you're spending 2 hours with me, trust me, you need to spend another 2 hours self-studying. If you're not doing your part, then I would not be able to commit anything. I can check your, I can take your interview, and I can check whether you'll be able to how your knowledge is, right? So if you follow whatever we are covering, right? Whatever being asked, ask questions. If you're dedicated, nothing can stop you. Mark my words. In writing, I can give you. Yeah, perfect. Anybody else?
Raushan, I have one question. If the post completion of the scores, if we have any doubts, can we connect with you?
Yes, yes. See, I'm gonna connect with you in WhatsApp. Okay.
Yep.
So if you see, there are some when you get enrolled, right? Let me show you if I can show you the WhatsApp group, WhatsApp channel. So, okay, let me show you. Okay. So this is my WhatsApp. So this is, let's say, one of the groups that recently concluded. I'm here in this group. You can ask me questions at any time, right? Yeah. So I'm in this group.
Okay.
So every group that we create, you will be part of WhatsApp dedicated group where you can connect with me. I'll be in the group. You can ask me questions, right? Definitely, we can connect.
Okay. So as I have checked the post, the session will be of 5 weekends, right?
Come again.
The session will be on 5 Sundays, right?
5 Sundays. I could not
The class.
understand that.
Okay, sorry. Let me rephrase it. The sessions that will happen will be on Sundays, right?
Saturday, Sunday, both weekends.
Both. Okay, okay, okay. So
Saturday 2
2
hours,
hours daily.
Sunday 2 hours.
Okay, okay, okay,
Four
okay.
4 hours a week,
Okay.
and so it's going to go for 3 months.
3 months. Okay.
So you think about the topics, right? And we're talking from scratch, so it takes time.
Roshan, what is the last date to enroll?
The course, it's going to be started. Okay, it's started today is the demo session. Next week is going to be the day one. So if you look at this, right, this particular link, in this link we have given you the day one. So on 30th June the day one will be starting. So next Sunday is going to be the day one. So it will be start on day one, and then it will continue 6 7 13 14th, it will continue. So this is the weekend you need to decide, right? And there are some live sessions available, right? You can go through this, right? You so yeah, that's your answer. Day one we are starting next Sunday.
Okay. And do you support the placement assistance? Like, is there any about any job openings in the market?
No, I don't have time for this. No, I don't do that. I just share knowledge is what I am passionate about, is what I do.
Okay, Roshan.
See, if you ask me questions, how to prepare, I can guide you, right? But I don't go behind companies and I don't do that. I can tell you where to go. Naukri, LinkedIn, that's the two best places. Okay, and just go there. You have knowledge, apply, do interview, recruit. So that simple, right? And throughout the course, I'm going to tell you what are the questions they're going to ask, what you need to prepare, hands-on demo, everything, right? So
Okay, Roshan. Okay, thank you.
technical things I'm going to take care. Okay, so yeah.
Hey Roshan, you said Saturday and Sunday. This shows Sundays.
just for one weekend. Okay, day one.
Okay.
After
Day
that,
two.
if you look at 6 7 13 14th, right, continues.
Okay. So next Saturday would be
Yeah,
just
this we will not be connecting. Okay, I have another demo session on next Saturday. Sunday, we're going to start.
Okay, makes sense.
Then we'll continue. There's no stopping. We cannot wait any longer. That's gonna be, so our batch gonna start on June. So trust me, it'll go till July, August, September. By the end of September, we'll be able to complete everything. And if you follow my instruction, you'll be able to have a great difference in the skill set or knowledge by the end of September if you commit yourself for. We need your time also, right, for all the practice.
Yeah, some things I'm looking for is like where you can locally download like an application, get it through Docker, try and like build it locally, push it up.
Correct. We're
I'm
gonna do
open
that.
for the things I think
Yes,
I'm looking for.
correct. We're gonna do that. Because we're gonna create using a Docker image. We're gonna create an application. We're gonna push in the Docker hub. We're gonna create a CI/CD pipeline using working with Jenkins. We're gonna do that. Everything.
Okay. Thanks.
So after this course, the possible roles that we can do from career switch, it'll be one is site reliability engineering that comes out obvious. What are the other possible roles based on the previous classes, or what do you think?
Okay. See, it depends on your current skill. Could you help me understand your current skill?
No, I'm in non-technical project management. Now I want to move to technical roles.
So do you want to switch as a fresher to technical?
Most likely, yes.
Correct. So you can switch as a DevOps engineer. You can switch as an SRE engineer. Those are best two options for you.
DevOps and SRE. Okay, sounds good. And if additional skills like, for example, SQL is required in detail, for them, it's better to, those are the things that we need to develop outside. That's my assumption. Is it right?
Understand. See, DevOps and SRE, yes, they talk about troubleshooting. See, basic understanding of SQL is definitely required, right? See, because there could be issue with SQL tuning. That's you're supposed to do SQL tuning. So obviously you will be able to on the databases part, not just SQL. Nowadays, database you're having no SQL database as well. So indexing and the SQL tuning are those two things that you are just not. So forget about RDMS, right? Relational. We need to also consider from the non-relational perspective, from DynamoDB, from MongoDB. How would you do indexing, or how would you do a tuning of the query, right? So that is like you need to improve along the career, right? So that's going to happen with the time. As a fresher, if you're trying to switch your career, whatever the things that is being covered here is will be good enough, more than enough for any fresher. With this course, anybody can justify 3 to 4 years.
Got it. Thank you.
Sure. Raushan, what's basically the SRE thing is? I'm not able to understand that. I'm into the Windows Server and I'm currently working as a Google Cloud engineer. So what's that exactly the role of SRE? I've seen
So
a
when
lot
you
of
say Windows Server, so you don't work in Linux?
No, I do not work in the Linux.
Okay. And when you say Google Cloud Engineer, so you work on GCP, right?
Yeah, correct.
Okay. So you know cloud, right?
Yeah.
You can create a server, storage, how it works, file systems, and all those things. The Google storage, and I'm not sure if you know GKE or not, Google Kubernetes Engine, right?
No, we are
No,
planning to
right.
implement it. That's why I have joined this course.
Okay.
Yeah.
See, your
Roshan,
what?
adding to the Ravi's question, one more clarification. What are the core technical skill to be an SRE, and what is it interrelated to the performance testing? Can you add this also?
Okay. So let me take both the questions separately. So coming to the Ravi's part, Ravi, so your domain, right, is on Windows.
Yeah, correct.
95% of the enterprise deployment is in Linux. You agree, right?
Yeah.
Ravi?
Yeah.
Right. So first of all, if you're looking beyond Windows, Linux is the way, right? You need to do that. You have to be good at Linux shell scripting, like you do Windows batch scripting you may be doing, right? So similarly, you need to upskill yourself on the Linux system. You need to understand Linux OS and shell scripting and things like that to be comfortable in Linux, first part. Coming to the SRE engineer, there are people working in Microsoft, those are also SRE engineers, but their expectation is on the Windows because Microsoft itself is Windows, most of the revenue, right? So it depends where you're applying. But in general, let's not talk about Microsoft and Windows. In general, if you talk from a SRE perspective, you need to be very good at Linux, cloud, any cloud, so which you are already know. Let's say you know Google Cloud, so you have that cloud understanding. You would be able to easily understand other cloud. But coming to the microservices part, I'm not sure how much you know. You know Docker because you're working in Windows, so I doubt because Windows we don't have Docker support and we cannot do containerization there in Windows operating system. So you need to understand, learn Docker, Kubernetes, right? You need to understand how the automation works uh, using Jenkins, using Terraform, Ansible, shell scripting, and that's what this SRE talks about. So coming to other question which was asked. So core skills of an SRE engineer is to make sure that the production is reliable. Your production is reliable. Think about it. We work Flipkart, we use Flipkart, Amazon, Swiggy. We don't want, as a SRE engineer, you are responsible to make sure that the customer has the best experience, and whatever it takes to make that success is the responsibility of an SRE engineer. If you're a senior most person, and there will be a team, right? I'm talking from a responsibility perspective, what an SRE engineer does. So the core skill of an SRE engineer is multi. You need to be good at cloud because things are in cloud. Issue could happen in anywhere. So the one of the most important thing is troubleshooting. You should be able to drill down the issue. Where is the root cause? Let's say issue comes, high response time or status code. I'm not getting 200 status code or CPU high. Could be any issue, right? You as an SRE engineer, you should be able to understand the root cause, do some quick troubleshooting, right? High CPU where, right? And that's where the performance engineers have the advantage if you have been troubleshooting applications, because most of the performance engineers are good at troubleshooting. They understand the issues, the various issues that can come up because they do the load testing and they basically try to understand the behavior of the application under load. So they have come across a lot of such issues already during the testing phase. CPU going high, right? Or SQL is slow SQL, or could be a memory issue, Java memory issue. They are good at looking into thread dump, heap dump, GC log analysis. I'm talking about the Java Spring Boot application, but still Java is the most popular enterprise level applications from the scalability perspective. So I'm taking mostly the Java application as the example. So that is what the performance engineer have the advantage of troubleshooting. So as an SRE engineer, the one of the important role, the most important role is to troubleshoot, narrow down the issue. If you need support from other people, yeah, you would get the support of developer. You will get the support of everybody in the organization, because making sure production is flawless without any issues is the organization level responsibility, not just one guy responsibility, right? If you think that the developer has to be called for this issue, you will call a particular developer. If you think somebody else needs to be in the call of troubleshooting, we do post-mortem, right? Blameless post-mortem, right? And we talk about the troubleshooting issues, right? We need to troubleshoot. SRE engineers are typically, so two skills if you ask me, 2 to 3 skills if you ask me. So troubleshooting part, and that would come after you understand the tech stack of the entire architecture. You should be having a good understanding of load balancer, how the routing works, different components in your architecture. If Kafka is there, you need to have a good understanding of Kafka. If application server is there, let's say Tomcat or WebLogic, you should have a good understanding of that. If your database is there, let's say MongoDB or DynamoDB or Cassandra, you should have a good understanding of that. Or depending on the other tech stack, what you have, you should have a thorough understanding of the architecture. Then only you can troubleshoot things. That's the simple thing. I hope most of you would agree. To troubleshoot things, we should be able to understand how the request is flowing. Yes or no? Everybody? All the performance engineers would agree on that part. So the troubleshooting is the most important skill what the SRE engineer should have. Second thing would be automation, because we talk about automation of various kinds, CI/CD automation. We talk about Terraform, infrastructure automation. We talk about configuration automation, right? We talk about cell scripting. Let's say some mundane task, some you need to execute some job every day. One job has to be run, let's say for the backup or so for some other activity. One job has to run. So you need to know how to write small cell script and do a cron job, right? Or Python scripting to do that. So the scripting part, the automation part. So the first thing would be troubleshooting. Second thing would be automation from the scripting perspective. And the third thing would be the cloud and architectural knowledge, the infrastructure knowledge. These three are the most important skill sets of an SRE engineer. And if you're looking for SRE engineer, high paying SRE engineers, 50, 60, 70 lakhs per annum, I'm talking about, whatever it depends on your skill sets, you'll be able to achieve in your career. If you know, because it's a very important job. It's an important work for any organization. All these companies, Flipkart, Amazon, Swiggy, they always have one SRE engineer. Guy
Roshan,
responsible.
automation in the sense functional application automation
No
or
automation.
infrastructure?
That is infrastructure automation I'm talking about,
Infrastructure.
or process automation I'm talking about. I'm not talking about functional testing automation. No. That's a QA job. I'm talking about the process automation. Any regular things that you need to do in production every day, right? That could be done using shell scripting or Python scripting, or I'm talking about the infrastructure automation using Terraform, which we have in the course, right? I'm talking about those kind of automation, eliminating toil, the mundane tasks, those kind of automation I'm talking about.
Can we say like this? If we have the 4 instances of the system during the in production, suppose one of the instance go down, debugging of that scenario, or how about it?
See, if you have one instance down, I can have an auto scaling group set up, and my one of the instance would come up automatically.
Oh, but it will come so, but load will be anyhow redirected, but the utilization will be more, no?
Absolutely, and that's what the performance engineer understands. That's why we always give a cushion of few servers extra.
Okay, at that type of scenario, how we will be doing the debugging? Is that a SRE responsibility to do the debugging, or infrastructure team will take up that activity? We only
Again,
just support them.
no. See, you need to, as an SRE engineer, we need to drive this first of all, right? See, infrastructure team. Okay, so you are thinking you have two different teams in the organization. Infrastructure team. See, infrastructure team can do that troubleshooting part definitely. If you have a, let's say, a dedicated team who is looking into the infrastructure, or if you're part of big SRE team and infrastructure is one of the sub team in the big SRE thing. So it depends on company to company. If one server has gone down, SRE engineer should be capable to understand the go over the logs and understand why the restart has happened. Forget about who does that, or you do it. But what I would say, what I have been doing, SRE engineer should be able to go over the logs, understand the logs, and understand the flow, why restart has happened. Check the CPU, memory, right? The logs part, how the calls were moving, what was called to call this restart, right? So they should be knowing. See, log analysis, metric analysis, all the monitoring analysis should be one of the skill of an SRE engineer. Let's say you have troubleshooted and the issue is with the code, you can ask the application development team that no, this issue, let's say you are always seeing the restarts, let's say you are troubleshooting things and you're always seeing the pod getting restarted because of high memory, let's say out of memory is happening because of memory leak issue. So obviously developer has to fix that. If you or performance engineers can help you do that. But see what I can troubleshoot things as an SRE engineer. This course, what this course would make you do, this course would make you take a heap dump, analyze that, and help the developers to find, to let them know that this is the way they need to fix the issue. Because as a performance, we have performance engineering also in this course covered. And that's what this course, that those things would take care of that, these things in this. So log analysis should be the skill, is the skill, not should be, is the skill of an SRE engineer. Not the code development. That's the role of a DevOps, a development team. See, what I'm talking about, a principal SRE, okay? Not talking about a senior. I don't know, you can help me understand what's your current years of experience, and whatever I'm talking from a principal SRE perspective. What a real full-fledged uh, SRE member should do. We should be able to do all such things I mentioned. I hope it makes sense.
Yes.
Okay, Ravi, I hope you answered the question, and other person who asked other questions with Ravi. I hope I could answer your questions, guys.
Yes, it's Mohan.
Mohan. So Mohan, I hope I could answer your question.
Yes.
Can we get this demo video?
Come again?
Can we get this demo video?
This recording session? Yes, you'll get it in the WhatsApp. You'll get it. Yeah.
Okay.
Any questions in the course part, guys? Anybody? Any questions?
What are the tools you are going to explore on this course? Different types of tools.
Tools in what context? Cloud part, we'll talk about services.
Service, you said debugging, no? For log debugging, any tools or infrastructure debugging, any tools you are giving as exposure?
See, it all comes under the log analysis. So if you look at this, so we have elk. See, either you use Splunk tool or elk. So to answer the question, we are using elk here to understand the log analysis, because these tools can capture the logs also. So elk is the tool that where you can use to get the log part. But again, once we get the log part, the understanding of log, how the flow is happening, that's going to be common. Right? Either you do it from Splunk. Again, depends on the company to company. If your company is using Dynatrace, AppDynamics, or New Relic, some commercial tools, you can see that those things from there. I'm going to demonstrate using elk.
Elk is a freeware tool or a commercial tool?
Open source.
Open source.
It has two flavor. Elastic Cloud is subscription based SaaS thing, but what elk we're talking about, is open source. Okay. Anybody else? Any questions?
Do we need any programming skills apart from
to be an SRE engineer?
Yeah.
Okay. See, automation scripting is important. Okay. Not the programming. I would not say you don't need to be a full-fledged developer, but you should be you should be able to do the shell scripting or Python scripting. Not a full-fledged development like a knowledge, but from the automation perspective. Let's say if you are going over 10 files daily basis, checking the logs manually, you should be able to find a way to write a shell script to automate that process, right? Or if you're doing a backup, regular backup at every day, you should be able to write a shell script or Python scripting to do that. Anything, shell scripting or Python scripting. So from the automation perspective, a SRE engineer should be good at, not from the programming development perspective.
Okay, thank you.
Okay, good. If we don't have any questions, we are good for the day. Okay. I'm in I'm in the WhatsApp group. Wherever you are, guys, you can find me. Right? You can find me. So I'll be there. You can ask me any technical questions. For other questions about the fees and all, you can contact Mr. Kumar. Okay. The course fee and all, how to enroll and all those things. Please get in touch with Mr. Kumar. For any technical questions, you can tag me and ask me. Okay, any questions on the technical part. Okay. Perfect, guys. So I'm gonna again share this link. Okay, please go over this link, and yeah, I hope to meet you guys soon. Yeah, next week. Thank you so much, everybody.
Thanks a lot.
Thanks, Raushan. Bye-bye.
Thank you. Bye-bye.